Right. Last class we discussed how to identify the centroid for using integration method. Right. We solved for rectangle, triangles, quarter circle, and also if it is a parabola or something we identified how to identify the centroid for this particular thing. Right. Now we will go for some basic centroidal formulas which you have to remember. Okay. The first one is a rectangle. So if I consider a rectangle, you know that area of the rectangle will be base into height and the centroidal location. If I consider what is the centroidal location in terms of x bar, so my x bar is b by 2, right? You can able to see it here, and my y bar is h by 2, right? This is for a rectangle, right? So you know what is the area, what is the x bar and y bar, provided this is my origin. This is my x-axis. So this is my y-axis, right? So based on that, we are plotting it. Okay. Then for a right angled triangle, so if I consider right angled triangle, so considering this as x and y, right? So your area is half into base into height, and your x bar from the base, so from this origin, it is 2/3 of b, and your y bar is 1/3 of h, so h by 2, right? So from the apex, it is 2 by 3b. From the base, it is 1 by 3b, right? The base is something you can able to see as a vertical line, right? So and this is a point, right? Similarly, so when you go for y-axis also, this is my apex, a single point, and this is my base. So this is a line, okay? So from the base, it is 1 by 3, and from the apex, this is 2 by 3h, right? And for a circle, you know, area is pi r square, right? So if I consider this is my origin, this is my x and this is my y, right? Then in that case, my x bar and y bar both are 0, right? Because the center point is your centroidal location, right? So what happens if there is a little bit change? If I say that my location is this, let me consider that this is my x-axis, this is my x-axis, and this is my y-axis, right? So let me consider this is my x, and this is my y, right? In that case, let me consider this is my diameter d. In that case, my x bar will be d by 2, and my y bar is also d by 2. Hope you can understand, right? Depends on the location of my axis. Okay. Similarly, for a semicircle, we consider a semicircle, and let me consider this is my origin, this is my x, and this is my y. In that case, my area is pi r square by 2, and my x bar is 0 because it is at the center, right? And the y bar is 4r by 3 pi. Y bar is 4r by 3 pi. Okay. So if I change my location, of course, based on that, you will get d by 2 or r. My x will be r. Y bar is again same 4r by 3 pi. There is no difference in your y bar, right? So based on different locations, you can able to see what is the centroidal distances, right? Similarly, if I consider a quarter circle, something like this, right? So here, so this is 4r by 3 pi, right? So this distance is 4r by 3 pi. Similarly, this is my other distance, which is 4r by 3 pi, right? I think in this case, my area is pi r square by 4. That is okay. My x bar is different. What is my x bar actually? This is my x bar. So if I look at here, right? If I look here, my x bar is this distance. This is my x bar. If this is my axis, right? This is my axis, which is x and y, right? My x bar is this one. This I have mentioned as 4r by 3 pi. So what will be my x bar then? So total age is r. So it is r minus 4r by 3 pi. It is r minus 4r by 3 pi. That is my x bar. Y bar, there is no difference. It is 4r by 3 pi. It is 4r by 3 pi, right? So it depends on the particular what you can say position of your circle, quarter circle. So if it is in different way, for example, if my quarter circle is something like this, so something like this, this is my quarter circle, then both x bar and y bar both is 4r by 3 pi, right? Because this is my center point, this is my base, right? So, but if my circle is in this like this, then the formula will change accordingly, right? So you have to note that. So based on the position also, you have to identify what is your formula related to that. Next, if I consider a sector of a circle, so the area for the sector of the circle is alpha into r square, right? And the centroidal location. So if I consider my x bar is 2r sine alpha by 3 pi. It's 3 alpha. But alpha should be in radians. You don't need to worry about it because this is not that much important. But anyway, so this is my formula. My x bar is 2r sine alpha divided by 3 alpha. Here you have to substitute alpha as angle degree. Here alpha you have to substitute as radians. Right? You have to substitute in both different cases. Okay. So based on that, you can also identify what is the sector, right, for a particular location, right? Most of the cases, you look after any figure. If it is symmetrical, if the figure is symmetrical, then your x bar or y bar will be half of the distance. Will be off, right? So, for example, if I consider the sector, let me consider the sector, right? So this is my axis. We can able to see that it is symmetrical about x-axis, right? So மேலையும் ஒரே மாதிரி இருக்கு, கீழையும் ஒரே மாதிரி இருக்கு. Symmetrical about x-axis. அப்போ y bar வந்து காமனா இருக்கு. Y bar னா, for example, if this is my distance, let me consider as a, right? So my y bar will be a by 2, right? Total distance by 2. Okay. So you can also look after the previous things, whatever we look after, so whatever we discussed. So rectangle, symmetrical about x-axis and y-axis. Rectangle is symmetrical about x and y. So that's why total distance by 2, h by 2 and d by 2. Circle, symmetrical about x and y. So d by 2, d by 2. Semicircle, it is symmetrical about only y-axis. It is symmetrical about y-axis. So my x bar will be d by 2. Y bar is not d by 2. Right? If it is symmetrical about y-axis, x bar is half of it. If it is symmetrical about x-axis, y bar is half of it. Okay, that will be based on that. Right? And similarly for the sector. Right? So whenever you see an image which is symmetrical, you no need to calculate. You can directly substitute it. So since it is symmetrical about x-axis or y-axis, it is total distance by 2. Right? You can directly go for it. Yeah. Now we will proceed with composite shape. So let us consider how to identify the centroid for a composite shape. So these are the things you have to do. First, you locate the coordinate axis. Locate what is the coordinate axis, right? So which means I am going to fix which is my origin. So which is my 0, 0. So for the entire shape. Once you split it, once you identify the coordinate axis, split your composite shape into simple shapes. Simple shapes is whatever we discuss. It may be a rectangle, a triangle, or a semicircle, or a quarter circle, or sometimes maybe a sector of a circle also. Based on that, you split your composite shape into that simple shape, right? Once you split that, determine the centroid for the simple shape using the formula whatever we discussed. After you identify the formula, then you identify the centroid by using this formula, right? Capital X bar is equal to sigma A into X bar divided by sigma A. Right? Similarly, capital Y bar is equal to sigma A into Y bar divided by sigma A. Right? So if you split into 3, your n is 3. So A1, X1, A2, X2, A3, X3 divided by A1 plus A2 plus A3, right? So it depends on this formula, right? To identify your X bar and your Y bar. You can use this formula to identify what is the centroidal location for the composite shape. Okay, right. Now we'll proceed with this. And we consider this is my shape. It's look very complicated, right? So what I have to do is I have to split this into simple shapes, right? So splitting you can add or you can subtract, right? So how to do that? So what I can do, I can consider this as a full rectangle, right? You know what is the dimension of the rectangle. You can identify what is your height and what is your width, whatever it is, right? So this rectangle is addition of your area, right? Then what I can do, I can subtract this triangle, right? Again, you know what is the shape of this triangle, right? You know what is the base and what is the height. You can identify from the dimension. This one should not be there. It should be subtracted. So subtracting this triangle. Then quarter circle. You consider this quarter circle. This also should not be there. Yeah, you are going to subtract. Okay. So when I add a full rectangle and subtract a triangle and a semicircle with respect to this, you will get that complicated shape, right? So this is how you can identify the centroid for simple shapes, right? You can identify the centroid for a simple shapes. Okay. Any doubt on this?
No, sir.
No, sir.
Okay. Right. Now let us solve the same problem. Let us solve the same problem. How you are getting the shapes accordingly, right? So what I can do? So let me consider. You put a table like this, right? The first thing is you have to put a table like this, right? So the table asks what is the shape, right? After splitting it, what is the area? What is your X bar? So actually this is X bar, right? What is my X bar? What is your Y bar? What is A into X bar? What is A into Y bar, right? You identified for different shapes, right? So for our case, you have 3 shapes, one rectangle, one triangle, and one quarter circle. So you want to split it into 3. Draw the shapes here, find out what is the area, X bar, Y bar for that simple shapes, then multiply it. Once you've done that, you add all your area, you will get sigma A, right? Add all your A into X bar, you will get sigma A X bar. Add all your A into Y bar, you will get sigma A Y bar, right? I think I have clear this because I already mentioned. So sigma A into X bar, and sigma A into Y bar. So now what I do to identify your capital X bar, use this sigma A into X bar divided by sigma A. You will get what is the answer. Similarly, capital Y bar, we can put sigma A into Y bar divided by sigma A, right? So this is the procedure to identify the centroid, right? You make a tabulation like this and you follow the steps accordingly, right? Now we'll proceed with that problem. Let me consider the same problem, right? So you have the dimensions accordingly. So now I'm going to split this. So whatever discuss. First one, it's a rectangle. It's a full rectangle. What will be my base? My base is 60 and 30. 60 and 30 is 90. My base is 90. What is my height? Height is 30 plus 30. 30. 60. So height is 60 and my base is 90. So this is my first rectangle. Next, your triangle. So this is my triangle, you can able to see. So my triangle will be like this. So you can able to get my triangle like this. So totally 90. Totally the rectangle is 90. Subtracting 45 here. So remaining base is 45. So this will be my 45 is my base. What is my height? Height is again 60. Right? Next, a quarter circle, radius is already given. So R is equal to 30. That is given. We can use that. Okay. So let us put in my tabulation. So this is my shapes. First, okay, before that, I am going to fix it. So already the axis is fixed. This is my axis. Right? I can able to see that. This is my right x-axis and y-axis. Okay. So I'm fixing my axis. First, putting a rectangle. So dimensions we identified. So it's 90 and 60. Now you know what is the area. So area is base into height. Right? So which means 90 into 60. Right? So we'll get what is the value for that. Next, x bar. X bar is nothing but b by 2. X bar is nothing but b by 2, which is 90 by 2, 45. Next, y bar is nothing but h by 2. So 60 by 2, which is 30. Now I can multiply this two, right? So 5,400 into 45. You'll get what is the value. Similarly, 5,400 into 30. You'll get what is the value. So this is my first step, right? So after we complete this, now we go for a triangle. My triangle is here, right? So it is having an offset distance of 45. Note, the position is important. Don't put the triangle on the origin, right? Your triangle is in a different location, right? So split it accordingly. So you split it accordingly, okay? So it's having an offset distance of 45, and you know what is the base of my triangle and what is my height of my triangle. Now area is half into base into height, right? So you can identify. So I'll put negative. Why I'm putting negative? Because I am subtracting this. So this is a positive one, this is a negative one. I'm subtracting. I want to subtract. So minus 45 into 60 divided by 2. Right? So you will get what is the value. Next, x bar. X bar is, so from the apex, it is 2/3 of b. Right? It is 2 by 3 of b. Plus, it is having an offset distance of 45. That also you have to consider. Right? So from this, I'm going to identify what is my x bar. So it has a force 45 mm plus 2/3 of b, right? So which means I can write it like this. So 45 plus 2 by 3 into 45, right? To get what is the value, which is 75, right? It is positive, don't put negative. So negative is applicable only if your triangle is on the other side. So this is in first quadrant. If your triangle is in second quadrant, you can put minus here. Okay, right. Now y bar from the apex, you know that it is h by 3, right? Which is 60 by 3, right? So which is 20. Now we can multiply it, right? So multiplying it, so minus into plus, we'll get minus, right? We'll get a negative term. Similarly, minus into plus, so we'll get a negative. So these are my terms. Okay? So the third one is to draw your notation. My position of my quarter circle is like this, right? So you know that your radius of this quarter circle is 30, and this is offset to 30 in y-axis, right? So at y, it is 30 mm offset. Okay, so this is what the diagram is. So now area, you know that pi r square by 4, right? Which is minus. So why I put minus? Because again, it is we are subtracting it. Okay, minus pi into 30 square divided by 4. What is the value, right? Like x bar, you know that it is 4r by 3 pi, right? So it is 4 into 30 divided by 3 pi. So that what is the value? Y bar, again, that is also 4r. It is 4r by 3 pi. Sorry, I think I made a mistake here, right? So what is your y bar here? So your y bar is plus 30 plus r minus 4r by 3 pi. So what you'll get, I'll get the values accordingly, right? So what I'll get, 30. So you can calculate. Sorry, I made a mistake, right? So you will get 30 plus r is 30 minus 4 into 30 by 3 pi, right? You will get something like this, right? So this by value with respect to your terms. So which is 30 plus 30 minus 4 into 30 divided by 3 pi, right? You are getting 47.26, right? This is my value, right? So I think here I am getting 42, so it should be greater than that. Okay, I will change it later. Okay, so 47.26. This is my value, right? Once you get it, now you can multiply this to. I will get it here, right? I'll get this is my value. The other one you will get it here. So this is actually this has to be 47. Right? 47.26, right? So I'll get a different value. So you're getting 706.85 into 47.26, right? So you'll get minus 33405.73, right? So now I got all my values. Only thing is I have to add, right? I'm going to add all my data with respect to that. Okay, which means I have to add this term, and this term. Right? When you add it, I'll get this. So 3343.142. Right? Similarly, I will add all these terms. So this one, and this one. Right? If you add it, you will get another value. Right? Next, I am going to add the other terms. So 162,000. So minus 27,000. So minus 33405.73. Right? So you will get 101,594.2. So this is my A into Y bar. Right? Any doubt up to this?
No, sir.
Okay. Now what I can do, I can find out. Right? I can find out what is my X bar. X bar into sigma A into X bar divided by sigma A, which means, so I know what is my values, right? 137, this divided by this, right? So I will get something like this. So 39.708. Similarly, Y bar. So Y bar, I will write it here. So Y bar is equal to 101594.27 divided by 3343.144. Okay, this is my Y bar. So you will get around 30.38, right? This is my location. So once you identify that, now I can locate it in my diagram, right? My X is 39.708 and my Y is 30.38, right? Any doubt in this?
No, sir.